Welcome to this video on aggregate functions in SQL. In this session, we will discuss what aggregate functions are, the different types of aggregate functions available in SQL, and some practical examples. Aggregate functions in SQL are functions that perform a calculation on a set of values and return a single summarized result. These functions are widely used in reports, data analysis, and queries involving grouped data. SQL provides several aggregate functions that help in summarizing data. The most commonly used aggregate functions are count, sum, average, max, and min. Let us look at each one in detail. The count function is used to determine the total number of rows in a table or in a specific column. It is often used when we need to count how many records exist in a data set. The sum function calculates the total of all numeric values in a specified column. This function is useful when working with the financial or statistical data. The average function returns the average value of a numeric column. It is useful for calculating average salaries, prices, or any other numeric data. Max function returns the highest value in a column, while min function returns the lowest. These functions are commonly used to find the highest salary, lowest price, or extreme values in a data set. Aggregate functions can be combined with the group by clause to generate summarized reports. For example, we can use group by to calculate the average salary per department. In summary, aggregate functions help in performing calculations on a group of values and returning a single result. They are essential in analyzing and summarizing large data sets efficiently. Welcome to this session on SQL window functions. In this, we will explore three important ranking functions: rank, dense rank, and row number. We will discuss how they work, compare their differences, and see practical examples. Window functions in SQL allow you to perform calculations across a set of rows while keeping individual row details. Unlike aggregate functions, they don't reduce the number of rows in the output. Let us see how ranking functions work within window functions. Ranking functions assign a position to each row based on the specified order. They help in scenarios like leaderboard rankings, employee salary comparisons, and ordered data analysis. Let us break down each function. The row number function assigns a unique number to each row in the result set, even if multiple rows have the same value. It is useful when you need to number each row uniquely. In this example, even though Alice and Bob have the same salary, they get different row numbers. There are no duplicate numbers. The rank function assigns the same rank to duplicate values but leaves gaps in the rankings sequence. In this example, Alice and Bob both have the same salary, so they share rank 2. However, the next rank is 4 instead of 3, leaving a gap. The dense rank function is similar to rank but does not leave gaps in the ranking sequence. In this example, Alice and Bob share rank 2, but the next rank is 3 instead of 4. Dense rank ensures no gaps in ranking. In this example, Alice and Bob share rank 2, but the next rank is 3 instead of 4. Dense rank ensures no gaps in ranking. Let us summarize the key differences. Row number assign unique numbers with no duplicates. Rank allows duplicates but leaves gaps. Dense rank allows duplicates without gaps. Welcome to this session on SQL window functions. In this section, we will explore how aggregate functions like sum, average, count, min, and max can be used as window functions to perform calculations without collapsing rows. Let us get started. A window function in SQL performs calculations across multiple rows while keeping each row's details intact. Unlike traditional aggregate functions, they don't collapse the result set. They are useful for analytics, ranking, and running totals. Yes, we can use aggregate functions as window functions by applying the over clause. This allows us to compute sums, averages, counts, and more across partitions of data while keeping all rows intact. The sum function can be used as a window function to calculate total salaries per department. Instead of collapsing rows, the total appears for each row within the department. In this example, the sum function calculates total salaries per department. John and Alice work in sales, so both see the same department total of 9,000. Bob and Eve see 11,000 for HR. The average function as a window function calculates the average salary per department. This is useful for comparisons and analytics. Count as a window function counts the number of employees per department. This is useful for understanding team sizes without grouping the data. The min and max functions as window functions allow us to identify the lowest and highest salaries per department while keeping all data visible. Here is a real-world example. We can analyze employee salaries by department using functions. Each row retains its details while displaying total, average, min, and max of salary per department. To summarize, the aggregate functions like sum, average, count, min, max can be used as window functions. This enables calculations without collapsing rows, making them powerful tools for analytical queries. Use aggregate functions when you need calculations like running totals, department-wise analytics, or comparing individual values to group statistics. Welcome to this session. In this session, we will learn how to convert a text value into a proper date format in SQL. We will take the example of 31 equal 01 equal 2021 and transform it into a valid date type. Let us get started. Why do we need to convert text to a date format? SQL treats text as a string, which means we can't use it in date calculations. Functions like dateDiff or dateAdd require valid date formats. Converting text to a date format ensures accurate results in queries. In some cases, dates may have non-standard delimiters like a equal instead of hyphen. We can use the replace function to convert 31 equals 01 equals 2021 into the correct date format 31 hyphen 01 hyphen 2021, making it easier to process. The convert function allows us to change text to a date using a specific format code. Here, we use 105, which represents DDMMYYYY. This ensures the text is correctly interpreted as a date. The cast function is another method to convert text into a date, but it requires the format to be YYYYMMDD. If the text is not in this format, cast may not work correctly. In SQL Server, we can use the parse function to interpret text as a date. By specifying the culture like ENGB for DDMMYY, we can easily handle different regional formats. Here is the final query that combines everything. It first replaces the equal sign with a hyphen, then convert the text into a proper date format using convert. This approach works in most SQL databases. To summarize, always check for different delimiters in text dates and replace them if needed. Use convert, cast or parse based on your SQL version. Choosing the correct format ensures smooth date operations in your queries. Hi everyone, welcome back to this session of ASP.NET and SQL Academy. In this session, we will learn how to extract only the first name from a full name column using SQL functions. Let us get started. Consider this employees table. It has a column called full name where each value contains a first name and a last name separated by a space. Our task is to extract only the first name. Let us break it down. Character index function, as an example, returns the position of the space. The left function extracts characters from the start up to that position -1. This gives us only the first name. Let us break it down. Character index function, as in example, returns the position of the space. The left function extracts characters from the start up to that position -1. This gives us only the first name. Here is the output of our query. As you can see, we have successfully extracted only the first names from the full names. What if the full name contains only one word like Adil? In that case, character index will return 0, causing an error. We can use a case statement to check if a space exists. If not, we return the full name as is. That's how you can extract the first name from a full name column using SQL. If you found this helpful, don't forget to share, like, and subscribe to my channel ASP.NET and SQL Academy. See you in the next session. Hi everyone, welcome back to ASP.NET and SQL Academy. In this session, we will learn about subqueries in SQL, how they work and where we can use them. Let us dive in. A subquery is simply a query that is written inside another query. It runs first and its result is used by the main query. We can use subqueries in different parts of an SQL statement such as select, from, where and having clauses. Let us say we want to find employees whose salary is greater than the average salary. First we calculate the average salary using a subquery. Then the outer query selects employees who have a salary greater than this value. Subqueries can be used in various parts of an SQL statement. We can use them in the where clause to filter data, in the from clause as a temporary table, in the select clause to calculate values, and in the having clause to filter grouped data. In this example, the subquery finds customer IDs from the order table where the order amount is greater than 5,000. The outer query then selects customers who match these customer IDs. Here we use a subquery inside the from clause as a temporary table named temp. Then we calculate the average salary for each department using the outer query. In this query, the subquery inside the select clause calculates the average salary of all employees. This allows us to display each employee's salary alongside the company's average salary. In this example, we first group employees by department ID and calculate the total salary for each department. Then, using the having clause, we filter out departments where the total salary is greater than the company's average salary. Subqueries make complex queries easier to write and understand, but they can be slower than using joins, especially with large data sets. Always consider performance when using subqueries. That's all about subqueries in SQL. If you found this helpful, don't forget to like, share and subscribe to my channel ASP.NET and SQL Academy. See you in the next session. Hi everyone, welcome back to ASP.NET and SQL Academy. In this session, we will discuss whether it is good to use the same subquery multiple times in a query and how we can solve this issue to make our SQL queries more efficient. Let us get started. Here is an example where the same subquery is used twice in the query. We are calculating the company's average salary twice, which is redundant and inefficient. Running the same subquery multiple times can hurt performance, especially with large data sets. When the same subquery is used multiple times, it results in redundancy. The same calculation is executed each time, which not only impacts performance but also consumes unnecessary resources. This makes the query less efficient. Instead of repeating the same subquery, we can calculate the average salary once in the from clause and then reference it in the outer query. This way, we only calculate the result once and it can be used multiple times in the query. In this optimized query, the subquery that calculates the average salary is moved to the from clause and is used in the outer query. This avoids repeating the same calculation and improves performance. Another solution is to use a common table expression or CTE. A CTE allows us to calculate the average salary once at the start of the query and then reference it in the main query. This makes the query easier to read and also more efficient. Another solution is to use a common table expression or CTE. A CTE allows us to calculate the average salary once at the start of the query and then reference it in the main query. This makes the query easier to read and also more efficient. The main benefits of using a CTE are reusability, readability, and improved performance. By using CTE, we ensure that complex calculations are only done once and the rest of the query is more efficient and easier to follow. That's all about handling repeated subqueries. By using the from clause or common table expressions, you can make your queries more efficient and easier to read. If you found this session helpful, don't forget to like, share and subscribe to my channel ASP.NET and SQL Academy. Hi everyone, welcome back to ASP.NET and SQL Academy. In this session, we will dive into the differences between the where and having clauses in SQL and explore when to use each one. Let us get started. The main difference between where and having is when they apply to the data. The where clause filters rows before any grouping happens, while the having clause filters after the data is grouped. Let us break down both clauses in detail. The where clause is used to filter rows before they are grouped. In this example, we are selecting employees whose salary is greater than 50,000. The filtering happens before any grouping or aggregation. The having clause, on the other hand, filters after the rows are grouped. In this example, we calculate the average salary for each department and then use the having clause to filter out departments where the average salary is less than 60,000. The where clause filters data before any aggregation or grouping happens, and it cannot be used with the aggregate functions like sum, average or count. The having clause filters data after grouping, and it is specifically designed to work with the aggregate functions. In this example, we first filter employees whose salary is greater than 30,000 using the where clause. Then, after grouping by department, we filter out departments where the average salary is less than 60,000 using the having clause. To summarize, use the where clause when you want to filter individual rows before grouping or performing aggregation. Use the having clause when you need to filter data based on aggregate functions after grouping the data. That's a wrap on the difference between where and having. Remember, where is for low-level filtering before grouping, and having is for group-level filtering after aggregation. If you found this session useful, don't forget to like, share and subscribe to my channel ASP.NET and SQL Academy. See you in the next session. Hi everyone, welcome back to ASP.NET and SQL Academy. In this session, we will be discussing SQL indexes, what they are, why we use them, and how they help improve query performance. Let us dive in. An index in SQL is like a table of contents for your database. It helps the database engine quickly find rows in a table without scanning the entire table. However, creating an index requires additional storage space and maintenance. We use indexes to speed up query performance. They allow the database to quickly locate the rows that match a search condition, reducing the need to scan the entire table. This is especially useful for select queries that involve filtering with where, joining tables, or sorting with order by. Here is an example of creating an index on the employee name column in the employees table. When you search for a specific employee by name, the index allows the database to find the matching rows faster rather than going through each record one by one. There are several types of indexes in SQL. A single column index is created on one column, while a composite index involves multiple columns. A unique index ensures that values in the indexed columns are unique. Full text indexes are used for advanced text searching. Indexes are most useful when you are working with tables or if you frequently query, sort or join tables on specific columns. They speed up retrieval operations by allowing the database engine to access data directly rather than scanning the entire table. Here is an example. Without an index, the database has to scan every row to find the employee named John. But with an index on employee name, the database can quickly locate the matching row, significantly improving query performance. While indexes improve query performance, they do come with some downsides. they consume additional disk space, and whether you insert, update, or delete records, the index must be updated as well, which adds some overhead. In conclusion, indexes are a powerful tool for speeding up data retrieval operations. However, it is important to balance the benefits with the extra space and maintenance required. Use index wisely on large tables and frequently queried columns to improve performance. Hi everyone, welcome back to my channel ASP.NET and SQL Academy. In this session, we will be discussing how to tune your SQL queries for better performance. SQL query optimization is a critical skill for improving application speed and efficiency. Let us dive in. SQL query tuning refers to the process of optimizing SQL queries to run faster and use fewer resources, which ultimately leads to improved performance of your application. Now, let us walk through some steps you can take to tune your SQL queries. The first step in SQL query tuning is understanding the query and identifying any performance bottlenecks. Review the query's logic carefully and look for unnecessary operations such as redundant joins, subqueries, or complex calculations. A good practice is to use the explain plan statement to analyze how the database engine executes your query. The second step is to ensure you are using proper indexing. Create indexes on columns that are frequently queried or used in operations like join, where, or order by. However, be mindful not to over-index as it can slow down insert, update, and delete operations. The third step is optimizing joins. Ensure that you are using the most selective join conditions and avoid joining unnecessary tables. Also, choose the appropriate type of join based on your data and requirements. For example, use inner join when you only need matching records and left join when you need all records from the left table, even if there is no match in the right table. The next step is efficient filtering. Always use where clauses to filter data as early as possible in the query. Avoid using or conditions in the where clause as they can force the database to perform a full scan, which is slower. Step 5 involves minimizing subqueries. While subqueries can be useful, they can also be inefficient where possible. Replace them with joins or common table expression CTEs, which can often lead to better performance. Step 6 is limiting the number of rows returned by your query. Use limit or top to restrict the number of rows, especially when you don't need all the data. This helps reduce the load on the database and the network. Step 7 involves analyzing the query execution plan. Use commands like explain or show plan to get insights into how your query is executed. Look for operations like table scans or sorts, which might indicate inefficiencies in your query. Finally, when performing large data modifications, consider batching the operations. Modifying a large amount of data in a single transaction can cause locking issues and slow down your database. Batch the changes to improve performance and avoid timeouts. Here are some final tips for SQL query tuning. Regularly update statistics to ensure the database engine has the latest information. Avoid using select star, it retrieves unnecessary columns. And consider partitioning large tables. Always aim to keep your query simple and focused on what is necessary for the task. To wrap up, SQL query tuning is a multi-step process that involves understanding your queries, using proper indexes, optimizing joins, limiting data, and using execution plans. If you found this session helpful, don't forget to like, share, and subscribe to my channel ASP.NET and SQL Academy for tips on improving SQL performance.